record on this computer. Okay, so the first example, 4/3 times 9/10. So like I said, it's literally this simple. You multiply the numbers on the top and you multiply the numbers on the bottom. It does not get any easier than that. Now, you could do 4 times 9 and make 36, and you can do 3 times 10 and make 30. However, you're going to have to reduce the fraction to smaller numbers. So you can do it one of two ways, and I'm going to do it both ways. And you do whatever you're comfortable with. For some of you, this might be, what I'm going to do first might be a better idea for you. I'm going to write all the numbers as smaller numbers. So look, I'm going to write 4 as 2 times 2. I'm going to write 9 as 3 times 3. 3 I'm going to leave there, and 10 I'm going to write as 5 times 2. And now all the numbers on the top and the bottom that are the same. Look, I'm going to do 2 divided by 2 is 1. 3 divided by 3 is 1. Now, this 2 is gone now. So you can't divide the 2 into it anymore because it's a 1 now. So what's left? 2, 3, and 5. He's gone, he's gone, he's gone, he's gone. So 2 times 3 is 6. And 5 times 1 is 5. Now, if you prefer, if you want to be more sophisticated, you can say, hey, I'm not a moron. I know that 4 divided by 2 is 2. 10 divided by 2 is 5. And I know that 3 divided by 3 is 1. And 3 goes into 9 3 times. You can do this too, whatever you're comfortable with. This, if the numbers are big, this is probably a better thing for you to do, okay? So 2 different ways to do the very easy problem. Don't just mindlessly multiply and say 36/30 and then reduce. What if the numbers are bigger than this? And they will be, because I'm going to give you an example where they're bigger. All right. So numbers got real big. And again, in the beginning of the semester, you have no calculator. So what are you going to do? 45 times 24 times 77? And even if you decided to take out a calculator and cheat and multiply it all out, you still have to reduce this answer to lowest terms. So what the hell are you going to do? What good is it to do 44 times 35 times 36? You can't do that. Now, if you want to start crisscross canceling, you can do that too, but I find that more confusing. So you're going to do, well, hopefully you're going to do what I recommend you do. I'm going to take all 6 of those numbers and I'm going to write them as products of smaller numbers. Now, sometimes there's more than one way to write a number, like 45. I could write 9 times 5. I could write 15 times 3. I mean, 36, I mean, I could write 36 tons of ways. I mean, I could use 9 and 4, 12 and 3. So as I go through this, I'm going to have to be kind of smart. For 45, I'm going to try 9 and 5. Why am I doing that? Well, I notice I have a 35 here. I can only write this with 7 and 5. And I need a 5 to cross it out. So I want to pick 7 and 5 here, so I should pick a 5 there. And if I pick 9 and 5, I should probably write 36 with a 9. I'll do it when I get there. So now 24, same thing. I have a bunch of choices. So I'm going to take a look at the bottom. I could do 12 and 2, right? Or I could do 8 and 3. But if you look here, 44, I'm going to do is 4 and 11. 77 is going to be 7 and 11. I want that 11, right? I'm looking at all the numbers before I decide how to break them down. So maybe I should use 4 and 6 for 24. I want to cross out real easy. Now 77, I have no choice. I have to use 7 and 11. They're both prime. So that one's easy. 35, same thing. I don't have a choice. I have to do 7 and 5. I hope you're realizing a lot of shit's going to cross out here. 36, again, I made the choice that I should use 9. You could write 36 with 12 and 3, but I don't have any 12s on top to cross out with it. So I'd rather use a number that I know will cross out, like 9. So let me do 9 and 4. Now, again, without a calculator, just take a damn multiplication table and have it next to you. And, you know, to help you break the numbers down. Now I got to start crossing stuff out. So I will. Let's cross them out in red. 9 and 9, cross out. 5 and 5, cross out. Put little 1s there so you know that they're gone. Let's see, that 4 will cross out that 4. This 11 crosses out this 11. This 7 crosses out this 7. Man, a lot of shit crossed out. Look at this. 1, 1, 1, 1, 1. Who's left? 6 is left. Gone, 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 gone. 4 is left. So I'm left with 6 over 4. Now, you could write 3 times 3, 3 times 2, 2 times 2. But you know what? These are even numbers. Cut them in half. When they're divisible by 2, just divide them by 2 in your head. Half of 6 is 3. Half of 4 is 2. So this whole big effing monstrous mess came out to 3 over 2, 1.5. When the number on top is bigger, this is called improper fraction, whatever. We don't give a rat's ass. You're not doing mixed numbers in here. I'm not going to write this as 1.5. I'm not going to write this as 1.5. I'm leaving it as 3 over 2, and so will you. Okay, this is your answer. But look at the little number we got. I would love to see you try and take a calculator and multiply all that out and come up with 3 over 2. I mean, this is the way you do it. You take each number and you write it as a product of smaller numbers, and then you cross out the ones that are the same. But you can't just mindlessly do it. You have to think. Sometimes there's more than one way. There's a bunch of ways to write 24. 8 times 3, 12 times 2. But I picked 4 and 6 because I wrote 44 with a 4. And I wanted to use a 4 so I could cross out the 4s. Even if you picked 12 and 2, you would have still got here. You just might have had to break down a couple more steps. All right? So, okay. So now a division one. And again, like before, I'm starting off with a basic one. So I have 15 over 7 divided by 6. You're like, what the hell? This isn't a fraction. You can't do this. It's not a fraction. You go, oh, shit. Okay. If they give you a whole number, you put a 1 under it. Any number can be made a fraction just by putting a 1 under it. 6 divided by 1 is 6. Now, keep the first dude the same, right? Keep change flip. You're going to flip this dude over, and you're going to change that to multiplication. So then you're going to do 15 times 1 and 7 times 6, right? You turn the division problem into a multiplication problem. Switch him to times and flip him over. So flip and switch. Flip, switch. So he flips, he switches. And then you do the business. Now, I do notice that 15 and 6 have a number in common that divides them both. I know that 15 is divisible by 3, and I know that 6 is divisible by 3. So again, if you want to write it all out, then write it all out, whatever you're more comfortable with. And yes, I'm going to keep that 1 there. It doesn't make sense to get rid of it because it might be the only thing left. So I wrote 6 as 3 times 2. I wrote 15 as 5 times 3. Cross out the 3's and multiply what's left. 5 times 1 is 5. 7 times 2 is 14. Alternately, if you decided not to do that, you could say, screw this crap. 15 divided by 3, 5. 6 divided by 3, 2. Same shit. You do 5 times 1, 5. 7 times 2, 14. Same thing. Whatever you prefer. If you want to do the crisscross thing, I would avoid doing this on the example I just showed you. That big monstrous multiplication with the 6 numbers. Don't do this there. You're going to get confused and lost in a sea of numbers if you start crisscrossing like that and doing this. Trust me, I've seen people do it and they F up the question. Okay, so I'd avoid that. So this is the last example. And again, like I just said, I'll do this both ways with the crossing out at the end. You have to flip, switch, right? You have to change it to multiplication. Don't try to do weird crisscross crap there, or you're going to multiply them. No. So flip, change, flip and switch. So he's going to flip upside down. Just go flip. You take the reciprocal. We don't use those words in this class. All right. That is what it's called when you flip the thing over. You're taking the reciprocal. All right. So flip, switch, boom. Now again, don't just do 15 times 36 and 27 times 25. This is retarded. You got to make the bottoms the same. That's addition. So again, you can do 15 as 5 times 3. You can do 30. Now, 36, I'm going to wait a sec. And 25, I mean, hello, 5 times 5. I'd like to see you write 25 another way. So look, I have 27 and I have 36. If you're able to spot in your mind the number that divides them both, you're good. I'm going to write 27 with 9 and 3 because there's no other way to write it. So now that I know I have a 9 here, now I'm going to write, I don't want to write 36 with 12 and 3. We could do 12 and 3 and then cross out the 3's, but then I have a 12 and a 9 and I have to do it again. I want to be more efficient about it. I'm going to write 36 as 9 times 4. Right? It's all multiplication. Everything on top gets multiplied and everything on bottom gets multiplied. You don't do 15 times 36. You don't do this, even if you had a calculator. So now I'm just going to cross out. That 5 crosses out that 5. This 3 crosses out this 3. This 9 crosses out this 9. Crap. Everybody disappeared. Nice. You're left with 4 and 5. Everything else crossed out. 5s, 3s, 9s. Done. The answer is 4/5. So now, like I said, if you spotted up here that 9 goes into this and 9 goes into this, you could have did it in one move. You could have said, okay, 15 divided by 5 is 3. 25 divided by 5 is 5. 36 divided by 9 is 4. 27 divided by 9 is 3. Oh, shit, 3/3. 3 divided by 3 is 1. This is why the crossing out can be really, you had to cross out multiple times. This can be, people screw this up all the time. All the time. I see mistakes when people do it this way. I see less mistake. How are you going to make a mistake here when you have all the numbers just sitting there right in your face? I mean, unless you did, 4 times 3 is 15, then okay, fine, you multiplied wrong. But as long as you break down the numbers correctly, you can't do this wrong. I mean, it's impossible not to do this right if you have the correct numbers there. Okay, so this is what I'd recommend you do, especially when you have bigger numbers, okay? So that's